This is what you're given in the FE handbook on hyperbolas, and you're also going to have this available on the exam. You're given the equation of a hyperbola here, and the hyperbola with the center at HK is the standard form of the equation. You're also giving the formula for the eccentricity, how to calculate B if you have A and the eccentricity, focus, coordinates, and directrix. Also, just to point a few things out, this point has the coordinates 0b. That means that this distance is b. And this point has the coordinates a0. That means that, I will quickly change my color. This distance is a. And then this point has the coordinates c0. That means that this distance in green is going to be C, or I call it the focus point, F. Focus distance. I would also like to add a few things that are not given in the FE handbooks, but are very important to know when solving the hyperbola problems. One simple thing to remember is that when your hyperbola is centered at the origin, in other words, when h and k are 0, so when your hyperbola is centered at the origin, the equation is going to look like this: x squared over a squared minus y squared over b squared equals to 1. And just for the sake of it, let's just assume the center of a hyperbola at minus 5, 3. So this means that the equation is going to look like this: x minus from the formula at minus 5 plus 5 squared over a squared minus y minus 3 squared over b squared equals to 1. Just something to remember when you have centered negative numbers. Just remember that the formula gives you comes with minus. So when you have a center at minus 5 minus a number, it's going to become plus. Another important thing to point out that it's not given in the FE handbook is the focus distance. So the focus distance, and this is a formula you'll have to memorize. Focus distance equals to square root of a squared plus b squared. In the FE handbook, you are given a hyperbola that is situated on the x-axis. This is x. This is y-axis. And the equation for this hyperbola centered at the origin, we've already discussed, is going to look like this: x squared over a squared minus y squared over b squared equals to 1. And something that it's not given in the FE handbook is the equation of a hyperbola that is situated on the y-axis. And the equation of a hyperbola situated on the y-axis is going to look like this, also centered at the origin, over b squared minus x squared over a squared equals to 1. So just notice how when you have a hyperbola on the x-axis, the x term is positive. And when you have a hyperbola on the y-axis, the y term is positive. And let's see why is that. Let's take this first situation where the hyperbola is situated on the x-axis. If we set y equals to 0, we get x squared over a squared. This term becomes 0, because y equals to 0, and this equals to 1. So from here, x squared equals to a squared, or x equals to a. So when y equals 0, x equals to a. So this point has the coordinates a, 0. Same thing, case number 2. If we set x equals to 0, we're going to get y squared over b squared. This term becomes 0 because x is 0, equals to 1. And then we get y squared equals to b squared, or y equals to b. So when x equals 0, y equals to b. So this point has the coordinates 0, b. Now let's go back to this hyperbola, to the first hyperbola, and let's see what happens if we set x equals to 0. So if I set x equals to 0, what do I get? I get this term is going to be equal to 0. I get minus y squared, b squared equals to 1, and I will get that y squared equals to minus b squared, and y equals to square root of minus b squared. So what I'm getting is an imaginary number. So this is not a solution. So that's why x never can be 0. The same thing is going to happen here. If I was to set y equals to 0, I will get x equals to minus x squared equals to minus a squared. And this is not a solution. I get an imaginary number. So one thing to remember, very important, if you were to just cover these graphs, if you forget about these graphs, imagine that they're not here. I want you to remember this, that if you are only given this equation here with x squared over a squared minus y squared, so an equation where the x term is positive, I want you to right away know that your hyperbola is going to be situated on the x-axis. So you're going to be placed on the right and left. And when you look only at this equation, you cover the graph, and you see the y term positive, I want you to right away know that your hyperbola is going to be situated on the y-axis, in other words, up and down. And next, let's work on a few examples. Which of the following graphs can represent the hyperbola x squared over 49 minus y squared over 9 equals to 1? See how important it is to know the fact that when you have the x component of this equation, or the x term of this equation positive, right? We know that your hyperbola is going to be located on the x-axis, situated left and right. So we can eliminate right away option B, and we can eliminate right away option C, correct? So now let's see how can we figure out, I'll rewrite that equation down here. So let's just set y. If y equals to 0, what do we get? I get that x squared over 49 equals to 1. And this means that x squared equals to 49, or x equals to plus minus 7. So right away, we found the value for x. And looking at the option number A, I'm seeing x here is equal to minus 3 and 3. Option number D gives me the value for x as minus 7 and 7. So there you go. We have figured out which of the following graphs can represent this hyperbola. The correct answer is D. Next, problem number 2. Choose the equation that can represent the hyperbola graphed below. So now we're giving these equations and one graph. So number one, we already know that when a hyperbola is situated on the y-axis, as it is here in this graph, we know that the y term is going to be positive. Or let me just write down the general form of this equation. We know that the general form is going to look like this. We're going to have y squared over b squared minus x squared over a squared is going to be equal to 1. So we know that this term that contains the y is going to be positive. So looking at the answers, right away we can eliminate a and b. Now between these two options, C and D, let's see which one is correct. The first thing to do is I'm going to take c x y squared over 16 minus x squared over 36 equals to 1. And if I set x equals to 0, I get the following. Y squared over 16 equals to 1, because this term becomes 0. And from here, y is going to be equal to square root of 16, and I get y equals to 4. Based on the graph right here, it looks like this is the hyperbola. So just for case number D, if we set this to x equals to 0, we get y equals to 6. So from C and D, right away we can tell the correct answer is going to be C. Moving forward, in problem number 3, the equation of a hyperbola is given below. X squared over 8 minus y squared over 27 equals to 1. What are the foci of this hyperbola? We've discussed at the beginning of this video the formula for the foci of the hyperbola. I'm going to write it down here. Focal distance equals to a squared plus b squared. Based on the equation I'm given here, we know that the equation of a hyperbola is x squared over a squared minus y squared over b squared equals to 1. So in this case, a squared equals to 8. That means that a is going to be equal to square root of 8. And this gives me that a is equal to 2 square root of 2. And b squared is equal to 27. And this gives me that b equals to square root of 27. So I just said equal this a squared, and this is b squared. This results that b is equal to 3 square root of 3. Looking at the answers, I think we're going to work with these values over here. So now knowing a and b, we can calculate the foci, all the focal points. Focal point can be plus minus. So we get plus minus square root of 8 squared plus b to square root of 27 squared equals to square root of 35. Okay, so let's draw a quick graph here. Based on this equation given in the example, in the problem, we know that this hyperbola is going to have, or is going to be centered at the origin. And based on the fact that the y term or the x term is positive, I know that this hyperbola is going to look something like this, left and right. Focal distance is going to be on the x-axis. So based on A, B, C, D, I'm seeing that the options that I'm going to have, or that I'm not going to have, I can because the focal distance here changes in the y direction. So this cannot be my options B and C. And we know that the focal distance is this and this. So I get square root of 35, 0, and minus square root of 35. This is going to be the coordinate of this point. We're going to have minus square root of 35, 0, and here square root of 35, 0. So the correct answer obviously is A. Next problem, write the equation of the hyperbola graphed below, whose vertices and foci are marked. Again, just looking straight at this graph here, I can see my hyperbola on the y-axis. I can right away from the get-go eliminate option A and option C and option D, actually. Maybe this was supposed to be y. No, I think this was supposed to be y because then, right, well, based on the answers given here, I can right away choose my answer is going to be B, just because of the fact that this hyperbola is situated on the y-axis. But I'm thinking that there might be a mistake here. Maybe, this should have been y to sort of make us do some more calcs. And this x, I don't know. So let's assume this is y and this is x. So we still don't know which answer is correct. So I'll take this out. So I just want to point out that just because this hyperbola is situated on the y-axis, we can eliminate A and we can eliminate C. So we're going to use the foci formula, which is square root of A squared plus B squared. And in the problem, we're giving the focal point at 5. So we know that F equals to 5. Also, we are giving this value over here, which based on what we've learned, this is going to be B is equal to 4. So our hyperbola has this form, y squared over b squared minus x squared over a squared is equal to 1. And if we set x equals to 0, we are going to get that y equals to b. So here b equals to 4 and is the y value. And now we can use the foci formula, the focal point formula, to calculate for A. So I know that, let's rewrite the formula like this. F squared equals to A squared plus B squared. And from here, we're going to calculate A squared equals to F squared minus B squared. So we can also write this as A equal to square root of F squared minus B squared. So we get square root of 5 squared minus B, which is 4 squared, and we get square root of 9. 25 minus 16 is 9. So A equals to 3. Okay, so my equation is going to look like this coming back here. Y squared over 4 squared minus x squared over 3 squared equals to 1. Or this is the same thing as y squared over 16 minus x squared over 9 equals to 1. Again, going back to the answers, we get B, which we knew from the beginning, but then I changed D so that it wouldn't be so obvious. I think I just made a mistake. So correct answer is B. The equation of a hyperbola is given as x squared plus 8x minus 4y squared plus 12y minus 13 equals to 0. Determine the parameters of the hyperbola. And based on the answers, we have to find the center of this hyperbola, A and B. So every time you're given an equation like that and you're asked to determine the parameters of the hyperbola, you have to think straight away about the method of completion of squares. So we have to bring this equation to the most familiar equation of a hyperbola. And as we've discussed before, the equation of a hyperbola can be x minus h squared over a squared minus y minus k squared over b squared equals to 1. And we've discussed that this is a hyperbola, which sits on a x-axis, right? This is x and this is y. And also we know that we have this equation of the hyperbola over b squared minus x minus k squared over a squared equals to 1. And this is a hyperbola that will be sitting on the y-axis. So we have to bring this equation given in the problem to one of these forms. And for that, let's see, we're going to use the completion of squares method, and that we're going to need these two formulas, which I was so very confident that this formula is in the FE handbook, and I hope it's there. If not, this is very simple to remember. When you have a plus b squared, the formula says this equals to a squared plus b squared plus the double of the product, 2ab. And when you have a minus b squared, this equals to a squared plus b squared minus double of the product. So just, this is very easy to memorize, to see how similar it is. The only thing different is when you have minus, the double product is negative. So let's rewrite this equation. X squared plus 8x minus 4y squared plus 12y minus 13 equals to 0. So we will separate the terms that have x, and we're going to rewrite them like this. X squared plus, I will make some room for b squared, and then I'll rewrite 8x. And moving farther, we're going to have minus, and I will open the parentheses because now I'm going to use these two terms, the y terms, and I'm going to open the parentheses because I have y negative and I need it to be positive. So I'm going to bring the negative in front of the parentheses, and then I'm going to change the sign to these two terms. So I will have 4y squared, and then I will make some room for my second term, which is b squared. And then, since I brought negative in front, this 12y is going to be negative minus 12y. And I will close the parenthesis, and I will bring 13 on the other side of the equal sign. So I'll have equals to 13. We have to add two terms here in order to complete the squares. And everything we add on this side of the equal sign has to be added on the other side of the equal sign to make the two sides equal. Okay, so here we have x squared plus, remember this term is 2ab. We know that our a is x, and 2b equals to 8. So what we have to do is just divide 8 by 2, and we're going to find our b. So a divided by 2, it's 4. So we found our b. And the formula says this is squared. Same thing on the other side. This is our a squared. We have 2y squared. And here we're going to have 2ab formula. And we know our a, so we have 2 multiplied by 2y multiply by b. So this all makes 4yb, yb, or 4by. So we have 4yb. So if we divide 12y by 4yb, we're going to get that b equals to 3. So b is going to be equal to 3, and we have to square this, equals to 13. So now we can write this equation here. We can write this is the same as x plus 4 squared. And then let me delete this down here. And then this is going to be equal, have minus. This is going to be equal to 2y minus 3 squared equals. So remember when I told you that whatever we add or subtract on one side of the equal sign has to be added and subtracted on the other side of the equal sign to leave the equation the same. So in this case, we are adding 4 squared on one side, so we have to add it here as well. So I'm going to do plus 16. And then we are subtracting minus 3 squared. I'm going to have to subtract 9 from this side as well. So 13 plus 16 equals to 20. Now, let's divide both sides by 20, and I will get x plus 4 squared over 20 minus 2y minus 3 squared over 20 equals to 1. So this looks more and more similar to the equation of a hyperbola. The only thing is here, instead of having y minus or plus k, I have 2y, so I have to get rid of this too. So this is going to be equal to, I have x plus 4 squared over 20. And here on this side, I will just bring 2 in front of the parentheses. So I'll have y minus 3 over 2 squared over 20 equals to 1. And this is going to be equal to x plus 4 squared over 20 minus, and let's see what can we do here. So 2 squared is going to be 4, so we can bring 4 outside of parentheses. So we're going to have 4 multiplied by y minus 3 over 2 squared over 20 equals to 1. And now we can reduce by 4. Here we have 1, and in this case, we're going to have 5. So let me rewrite this. And I will move all the way here with the star. So I'm going to rewrite this as x plus 4 squared over 20 minus y minus 3 over 2. You know what? Let me rewrite 3 over 2 as 1.5 to make it more similar with the answers we have. So 1.5 squared over 5 equals to 1. I will write this as x plus 4 over square root of 20 squared minus y minus 1.5 squared over square root of 5 squared equals to 1. And then one more time, x plus 4 squared. Square root of 20 can be written as square root of 4 times 5. And square root of 4 is 2. So I can write 2 square root of 5 squared minus y minus 1.5 squared over square root of 5 squared equals to 1. So now it's very easy to identify the center of this hyperbola, the A and B. So we're going to have center of this hyperbola, very easy to identify. It's going to be minus 4, 1.5. So this is the center. And then A, it's going to be equal with 2 square root of 5. And B is equal to square root of 5. So let's look at the answers. Which one is the correct answer? Center minus 4, 1.5. Looking at the A equals to 2 square root of 5 and B square root of 5. So it seems as if A fits the bill here. Just want to make sure there's nothing else. So this is minus minus. This is, yep, the correct answer is A.